Analog data is continuous, allowing for an infinite number of possible values. A sound wave is an example of analog data. Digital data, on the other hand, only has two possible values, 0 or 1. To be handled by a computer, analog data has to be converted to digital, or digitized. The process of digitizing sound is known as sampling. Sampling an analog sound wave involves measuring the amplitude of the signal at regular intervals. The quality of the sound depends on the sampling rate, which is the number of samples taken per second measured in hertz. It also depends on the bit depth, which is the number of bits used to store each sample. The more frequent the samples, the closer the digital representation is to the original analog signal. You can see that this waveform isn't a close match to the original. However, if we increase the sample rate, we get a closer match. You can calculate the file size of a sound using the following formula. The sampling rate in hertz times the bit depth in bits times the number of channels times the duration in seconds. If the sound is in mono, it will have one channel, and if the sound is in stereo, it will have two channels. For example, a sound file with a sample rate of 4000 Hz and a bit depth of 2 bits, which is in mono, so has one channel, and is 10 seconds in duration, will have a file size of 80,000 bits. You can calculate the bit depth of a sound using the following formula. We can use this to find out the bit rate of the file we were working with just a moment ago. As you can see, it equals 2 bits. Compression is the process of reducing the size of a file. It allows us to reduce the amount of storage space we use to speed up the transfer of files over networks. There are 3 types of compression: lossless, lossy, and superchannel. Lossless compression reduces the size of a file while retaining all of the original data. Lossy compression reduces the size of a file by permanently removing some of the data. Superchannel is a form of compression where special data is selected for a special reason. These data are separated from the rest, and the rest are thrown out. One of the simplest methods of lossless compression is run-length encoding, or RLE. It takes sequences of repeated values and compresses them. For example, there are 3 A's in a sequence, so this can be shortened to 3A. There are then 4 B's in a sequence, so this can be shortened to 4B. Finally, there are 3 C's in a sequence, so this can be shortened to 3C. Run-length encoding can also be applied to bitmap images by writing the number of pixels followed by the value in brackets. For example, in the first line of this image we have 1 white pixel, which is represented by 1, followed by 3 black pixels, which are represented by 0, followed by 1 white pixel, which again is represented by 1. Encryption allows data to be kept secret and secure so no one else can make use of it. A key is used to encrypt plain text into meaningless ciphertext. The same key is then used to decrypt the data back into plain text. A simple method of encryption is the Caesar cipher. It works by shifting the letters in the alphabet by a set number of positions. For example, a shift of 3 would turn A into D. B becomes E and C becomes F.